Hello everyone, today I'm going to be looking at some of the review. We are going to go ahead and get started with the first couple, which we already did some of these in class, so some of you may want to go ahead this next couple minutes. Okay, but the first one that we're looking at is 32 to the negative 3/5. Approach this is I would take this 32 and I would break it down. Okay, 32 is 4 times 8 times 2. 8 is 2 times 4. And 4 is 2 times 2. Look along the outside. 32 is 2. Now I would replace 32 with 2 to the 5th. And then I would write to the negative 3/5 power. Okay, the reason that I do that is because now we can use our rules of exponents. We know power to a power, we're going to multiply the exponents. So instead of with 2 to the negative 15 over 5, which is 2 to the negative third. And so now we've got to talk about the negative. Negative powers. So instead of 2 to the third, or 2 to the negative third, excuse me, it becomes 1 over. And the final step of this is actually multiply. So 2 times 2 times 2, or 2 to the third, is just 8. So my final answer for number 1 is 1/8. Number 2, again, if you go ahead and look at the problem, the first thing that I noticed is that there's that negative exponent. So this time, we'll do this problem with radicals so you can see a little bit different. Negative. So negative power, we said it's going to take 64 and send it to the denominator. However, if there's something in the denominator, it's going to send it back to the numerator. So 27 and 64 switch places, which gets rid of the negative 1/3. Okay, so now we can write this as a radical. So I have a radical 27 and a radical 64. Denominator of the fraction is what becomes the index. Root. Cube root says that we are looking for groups of 3. 7. And I'm going to split it down into 3 times 9. 9 is 3 times 3. And if you notice, there are 3 3's, so the cube root of 27 is 3. Okay, cube root of 64, we're going to target the same way. So I've got, okay, 8 times 8 is 64, which is 2 times 4, and we said 4 was 2 times 2. 8 is 2 times 4, again, which is 2 times 2. You see, we have a group of 3 2's, and we have another group of 3 2's. So we have a 2 that comes out, and another 2 that comes out. Okay, together, 2 times 2 gives me 4. So my final answer that I'm looking for is 3/4. And the last one, there's a couple different ways that we can approach this. The first one, if you want to write, there's like an imaginary 2 there. If I took this radical and I wrote it as an exponent, it would become, we have 6 to the first, becomes the denominator. So it would be 6 to the 1/2. And we're looking at 6 to the 1/2 to the 4th. Again, we said power to a power we multiply. Comes 1/2, where 1/2 of 4 is just 2. And 6 to the second can be replaced with 36. Okay, if you don't like that way of doing it, another thing you could have said was root 6 to the 4th is root 6 times root 6 times root 6 times root 6 4 times. Root times itself gives you back what you started with. So square root of 6 times square root of 6 is 6. And again, square root of 6 times 6 times square root of 6 is 6. Times 6 is still going to give you 36. Okay, so there are the 3. Okay, the next 3, if you look at the directions, they ask us to write in. So we're not going to have radicals in our answers. We're going to leave things in terms of exponents. So I'm going to look at this first one. I can put a 2 to the first. And we're just going to take this index, and we said it's going to become the denominator of all of these fractional exponents. First, and it's now 2 to the 1/5. The radical goes away. The third becomes x to the 3/5, and y to the second becomes y to the 2/5. Since we can't reduce those fractions, since we can't simplify those fractions, that problem is now complete. Which leads us to 5. So this is one of my favorite ones. Again, if you need to come put a little 2 there every time we have a square root, go ahead and put the 2. This is again to play upon those properties. A to the 5th starting point. So this 3, which is the index, can now come and become the denominator. Okay, so mentally what we've done is we've taken care of the a to the 5th, and we've taken care of the. So now if you look, we have this square root. So everywhere we see the radical, I'm going to, from now on, put parentheses, and square root becomes to the. So now we can kind of mentally blotch out this square root. Yeah. The last thing that I see that is left is the 6th root. And the 6th root becomes to the 1/6. Take care of everything. So this whole radical has gone away. And we now have this entire piece in exponential form. What we have to do is take power to a power to a power. To a power we multiply. So multiplying fractions, we multiply the numerator. So 5 times 1 times 1 is 5. 3 times 2 is 6. It's 36. If that fraction reduces, we're going to reduce it. Since it doesn't, we are done. And I will note, if the directions were different and it just said to simplify, 36 and put it back to the index. But because this problem says leave an exponential form, then I would rather see over 36. Okay, but if you wrote it this way, it's equivalent answer. Okay, so that leads us to the last one on the page. In this one, if you look at the indexes or the exponents do not all match. So we're not going to convert this to radical form. You'll also notice there's a pi, and we don't really want to index a pi. So we're going to use our rules of exponents. To use exponents, to use exponents, we said we have to have the same. Well, if you look, 5 is here, and we have 5 here. So this is the problem. So my question is, can we make 25 to the 1/2? You can do this 2 ways. The first thing you can do is say, okay, well, 1/2, isn't that just the square root of 25 to the first? And the square root of 25 is 5. So here's my real problem. We have 5 to the pi times 5 to the 2 minus pi. Now, divided by 5. And you could write 5 to the first if that makes you feel better. Okay, or another thing you could have done is say, okay, well, 25 is 5 times 5, or 5 to the second. And 5 to the second is 5 to the first. Either way, 25 to the 1/2 turns into 5. So now we're going to play on our rules of exponents. We said when we multiply, same base, we add the exponent. So the first two we're going to add pi plus 2 minus pi. And if you notice, those pi's are just going to, that gives us 5 to the second. The second divided by 5 is just 5. When you divide, you subtract their exponent. Answer I'm looking for, it's 5. Couple, we are looking to leave in, oops, I don't like that code. And we are looking to leave in radical form. A radical form means we're going to leave the radical. So I'm going to start with 7. What I'm going to do is take the 5 and write it index. And this becomes the 5th root of a to the, okay, here's step 1. It is talking about the word simplest. So we now have to see if we can take anything out of this. Are there groups of 5 and 17? So to get to 17, I have 5. Another a to the 5th would be 10. Another a to the 5th would be 15. 15, we need 2 more. Okay, all even groups of 5 come out. So we're going to bring out 1a, 2a, 3a's, which is an a to the 3rd. And then the 5th root of a to the 2nd is what is left for that one. Number 8. The cube root of 16 times the 6th root of 64. A couple different ways you can do this. First of all, though, to be able to multiply these radicals, we have to have the same. Now we don't. We're going to convert this to exponential form, and before we do, we're going to see if we can break down. So I've got 16. Okay, 16 is 4 times 4, which is 2 times 2. So 16 is 2 to the 4th. Okay, then I'm going to do the same thing with the 64. Okay, 64 times 8, which is 2 times 4, which is 2 times 2. 8 is 2 times 4. 4 is 2 times 2. So if you count, there are 1, 2, 3, 4, 5, 6. So 2 to the 6th. So here's what's cool. 16, 4. I can then take the index and make it or the denominator of the fraction. This becomes 2 to the 4 times. I'm going to take 64 and replace it with 2 to the 6th. Same idea, the 6 is now going to become the denominator of the fraction. Okay, so what I'm left with here, 6 divided by 6 just turns into 1, so I have 2 times 2 to the 4/3. Okay, anytime we can reduce and take out our perfect groups, then we're going to. So another way you could write 2 in the 4/3 is 2 times 2. And the reason that we're going to do that, so what we end up with is we have a 2 that's a whole number. We have 1/3 that's left over. So we have cube root and then times another 2. Okay, so all together, we end up with 2 times 2, which is times the cube root of 2. Okay, which leads us to the last one. Same type of thing. The index doesn't match, so we can't use radicals. Notice this time they give you matching bases. So I'm going to write this as 2 to the 5/3, 2 to the 1/4. Multiply powers with the same base. You keep the base, and you add the exponents. So I now have 5/3 plus 1/4. Okay, my goal here is to add those two together. In order to do that, we have to get a common denominator. I can make 3 and 4. So I've got 5/3 plus 1/4. I want to make those both become 12. And to get 3 to become a 12, I multiply by 4, so the 5 becomes a 20. To get the 4 to become a 12, I multiplied by 3, so the 1 becomes a 3. 23. Okay, from here I can then convert it back, so I end up with 2 to the 23 over 12, and the 12 goes back to the index. So this is now the 12th root of 2 to the 23rd. Okay, we're looking for groups of 12. So if I come over here, I have, 2 to the 12th. To get to 23, I am missing, so my even group of 12 comes out, and I have a 2. So this 2 to the 11th is second side, so I end up with the 12th root to the 11th, and you can leave it like that. Okay, I'll try to keep this. So now we can look at the next couple. We're going to do 10 the same way. We want 4 to have a base of 2 since the index doesn't match. It's 2 times 2, which is 2 to the 2nd. So 4 becomes 2 to the 2nd. The cube root then turns into the denominator. On the other side, same thing. We have 2 to the 1st, and now divided by 4. The goal is to add these together since we're multiplying. Again, 3 and 4 can both become 12. So I'm going to make this 12. 12. To make 4 become 12, I multiply by 3. 3 becomes 12, I multiply by 4, so the 2 becomes 8. And I end up with 11. This time there are no even groups, so my final step is going to take 12 and put it back to the index. So my final answer is the 12th root of 2 . Okay, 11 is the same process, so I want you to try this one. I'll get you started. Okay, the square root becomes 2 to the 1/2. Root becomes 2 to the 1/3. The 3 you're just going to multiply and keep out in front. When your goal is to add the 1/2 and the 1/3, you can try this one on your own, but I will tell you the answer to number 11 should end up being 3, 6 root of 2 to the 5th. I say 12. Notice they do have the same base, and we're dividing. Okay, dividing tells us we are going to subtract the exponents. So I have 10 to the root 3. Subtracting root 3 minus 1. And what's tricky about this one is this negative has to go through to both. So this becomes 10 to the root 3. Well, these root 3's are going to cancel. And I'm just left with 10 to the first, which is just 10. Okay, 13, same kind of process as the last one. 2 to the root 3, or sorry, to the root 2. Multiplying tells me we are going to add the exponents. So I'm going to add, okay, root 2 minus root 2 is just going to be 2 to the first. Or sorry, let me rephrase. Root 2 minus root 2 is 2 to the 0. And 2 to the 0, anything to the 0, is just the number . Okay, so we're going to look at a couple of these, maybe not all of them. Notice it says assume all radicals denote real numbers. All that tells me is that I do not have to worry about absolute values on these problems. I'm going to start with 15. 15 has a fourth root, which tells me I'm looking for groups of 4. So I have 9 times 3. Okay, no groups of 4. That one. Then I'm going to look at u to the, I have a u to the 4th times u to the, I'm going to circle groups of 4 and underline. Okay, so one group of 4, so I know that u, then have a v to the 8th, which is a v to the 4th times v to the 4th. This time there are 2 groups of 4, so v to the 2nd comes out. If it doesn't have a group of 4, so we said that 3 times 3 are 9, then it's stuck inside 4 for that one. Again, if you notice the index doesn't match, so I'm going to help you get started, but I want you to finish this one. You have an a to the 5/6, a to the 1 combined. So again, try this one. You end up with a times the cube root of a. Okay, 17. First thing when you're dividing, I want you to see if you can simplify. So first thing I notice is that those a's are going to cancel. Second thing I'm looking for is to bring out groups of 2. So I now have the square root of b squared over the square root of c to the 3rd. Squared 2, so the square root of b squared just becomes b. Well, c to the 3rd is a c squared times another c. C's comes out, so all I'm left with is the square root of c. And this is pretty simplified. The only thing that we don't like about it is that root c in the bottom. That we're going to multiply fancy one by the square root of c. Times square root of c on the bottom just gives you c. So I have a c that was already there, and I now have another c. On top, b times root c is just b root c. So my final answer is b root c. C times c is c to the 2nd. So all over c to the 2nd. All right, so let's look at 18. 18 is kind of tricky because there are two pieces, but under the radical, there's only one on top and one on bottom. So I have the square root of x minus 1 of x plus 1. Again, there are two things in the denominator, but they're all inside one radical. Fix this is to multiply plus 1 times square root of x plus 1. The square root times itself always gives you back what you started with, x plus 1. If I do it to the bottom, I have to come do it to the top. So once I do this, I end up with the square root. I don't know what the heck is wrong with my line here. Hold on. Okay, I end up with the square root of x minus 1 times x plus 1. So all I have to do is multiply this out. Now, if you notice that these are conjugates, you can use our multiplication shortcut. First times first, so we've got x squared minus last times last, which is over x plus 1. And this next view, we're just looking to simplify, write our answers in radical form. This time you do have to use absolute values, so I'll give you a reminder. You're going to put absolute value when the index and then the second thing has to have an odd power. I don't know if you can see that, so I will rewrite it. Okay, when the index is even, power, answer, absolute values. Okay, other than that, we're just going to look for our groups. One, groups of 3 and negative 16. Negative 16, all that tells me if it's odd, we can do it. If it's even, we can't. It just means my answer is going to be negative. 4 times 4. We've got 2 times 2 and 2 times 2. If I have a group of 3, it comes out of the radical. If I don't have a group of 3, so this third or fourth 2, it's stuck inside. Negative 2. Okay, 20, I'll let you do. You're doing the same process, but looking for groups of 4. And if you don't see an index, there's so we've got an even, possibly absolute values, and groups of 2, so I'm going to take 9. 9 is 3 times 3. I have a group of 2 3s. Okay, a to the 8th, well, we have 2, 6, 8. There are 4 groups of 2, so a to the 4th. The third is a y squared, but there is one y left over. So y to this. One of these y's comes out, and the other y is stuck on the inside. So I'm going to go ahead and circle this. Then look for any odd powers. Okay, if you notice y to the first is an odd power, put values around the odd power. Which leads us to the last one here. 22, we are looking for groups of 5. Even, odd, so we don't have to worry about it at all. So I've got my 32, just 2 times 16. 16 was 4 times 4, which was 2 times 2, and 2 times 2. And if you look around the outside, 2's, so we're going to bring out a 2. A to the 15 has 5. 15, so there are 3 groups of 5, so a to the third comes out. and b to the 10th has 5, 10, and so b to the 2nd comes out. Again, since it's odd, we don't have to worry about absolute values. We can just go ahead and move on to the next one. Okay, so in some of these, I'm going to let you try on your own. I will go back over 26 one more time. Use absolute values. Groups of 4 and 2 to the 4th. Well, they kind of give us that. There's one group of 4. We can bring out a 2. Is x to the 4th times 1 more, so we can bring out one group of 4, x. Other x is stuck on the, and then y to the 8th has got 4. There are 2 groups, so I can bring out a y to the 2nd. Reminder, since we had an even index, anytime we have an odd power, so you see how we have an x to the 1st, absolute values around our answer because they don't tell us necessarily that everything is positive here. Okay, we're now going to get to some multiplication and division. Radicals, you have to have the same index. So if you notice, the index match, so I'm going to keep the root 3 and multiply. Becomes 81. X times x squared, third. Looking for groups of 3. So I'm going to take 81, which is 9 times 9. 9 is 3 times 3. 9 is 3 times 3. And I have a group of 3 3s that can come out. And 1 3 that is stuck inside. X to the 3rd has a perfect group of 3. I can bring x out. Since the index was odd, we don't care about absolute values. So we are good with that one. 8, you're going to do the same way, but instead of looking for groups of 3 afterwards, you're going to look for groups of 2. Okay, so 29, this is simplified. The only thing I don't like here is this root 7 in the denominator. Okay, the way we get a square denominator is to multiply. So 1 times root 7 in the numerator becomes root 7. In the denominator, root 7 times root 7 just becomes, and I end up with the square root of 7 times 14. Okay, 30 is the same type of thing, but we have a cube root. So we need groups of 3. We've got the cube root over the cube root of 2b. Apply by our fancy one, we know we're going to have to do cube roots. So here's how this works. We have 1, 2. We need groups of 3. So I'm going to multiply by 2 to the, I have b, I need b to the 3rd. So again, I'm going to multiply b to the, we'll come up here and we'll talk about the numerator, but let's just talk about what I just did for a second. So I now have the cube root. I have 2 times 2 to the 2nd, which is 2 to the b times b to the 2nd, which is b to the 3rd. Group of 3 here, group of 3 here, 2. We can bring out a b, and we no longer have that radical in the denominator. If we do it to the, do it to the numerator, multiply by 2 squared b squared. So we end up with 3 squared times b squared. So now we just have to multiply this all together. 3 times 2 times 2, or 3 times 4 becomes 12. We have an a, we have a b squared. done with that one. Okay, this is the same process, so again, I'll give you a chance to try it. The answers will be posted on Edmodo if you're having a hard time. Okay, this one, 33, we can go ahead. It's kind of tricky, but it's not big. We're looking for groups of 4, so I take the number 4. However, if you look at the A plus 2B, there are 4 of them. A group of 4 A plus 2Bs. Bring out A plus 2B. And then the 4th root of 4 is left. Okay, if you notice again, even, we're going to slap absolute values around the A plus 2B. I'll leave the 4th root of okay, 36, let's look at. It's an addition problem. To add, we have to have the same ending. And root x, so 4 root x plus 3 root x just gives me 10 root x.